Hello students, welcome once again to our Tejas series. Please do like and subscribe. Like the video and subscribe the channel. If you people are really getting benefited and you feel that these videos, these questions are really beneficial for you, then I will again request you all to please like, share the video and do subscribe the channel. See, those are the questions. See, that's the question which you have, whose solution we are going to discuss today. Okay, so those were the two questions which you would have got today as a pose. So let's start with the first one. See, the type of integration, indefinite integral question we are focusing, so that we can like cover almost every aspect of the chapter, the most important being the method of substitution. Okay, there are so many, like integration by parts, partial fractions, so we will try to cover each and every aspect, and few special tricks also, special substitutions also. So let's start. So the first one is integral of 1 plus x upon, so we have to integrate this, so which is integral of 1 plus x over x into 1 plus x times e raised power x whole square, of course with respect to dx here. So this is what we have to integrate. Okay, see, as I always say, there's nothing called chain rule in integration. So whenever you have a function within function, the first thing that strike our mind is to assume the inside function, like replace it with some new variable t. Now what's the case here? The case here is this one. Okay, so that's a square function, and within that function you have one more function which is 1 plus x times e raised to the power x, bacho. Okay, so what I will suggest here is, I will say, okay, let us replace the entire thing, or maybe just x times e raised power x by t. Now let's differentiate. Of course we need to differentiate. So what we will get as derivative? So you will get it as x e raised power x using product rule for differentiation in LHS, and then we will get e raised power x dx as dt. Okay, but you see here in the numerator along with dx we have 1 plus x. So if I take e raised power x common, so 1 plus x times dx is dt. So that means I can replace the numerator term along with dx by dt by x into, so this x will actually appear in the denominator, and when it gets multiplied with x, you can replace x into e raised power x again by t. So what integral we get here? We get this as our integral, bacho. So first step, as I said, the most important one in indefinite integration, the method of substitution, where if we can substitute a function by a variable, okay, whose derivative also can be removed along with dx, so that really makes the integral simple, as you can see here. Now which form is it? Of course that's a form for partial fraction. So let's move ahead. For partial fraction we will say, okay, 1 upon t into 1 plus t whole square. So we know for every linear factor in denominator we introduce a constant. So that's again, so I will be writing 1 plus t whole square as 1, okay, actually I put square first, so this should be the case. Okay, so one term c upon 1 plus t and b upon 1 plus t whole square. So taking LCM in RHS and then simplifying it, so we get a times 1 plus t whole square plus b t plus c t times 1 plus t. Now how can we get the values of a, b and c? So there are two ways. One, you can open the polynomial form in RHS, then compare the coefficients for the respective terms like t squared, like t, and the constant term. You will get 3 equations in 3 unknown. But what I prefer here is that, okay, let us replace the value of t which we get by equating the linear factor with 0. So if I equate the linear factor t with 0, of course t is 0, so put t equal to 0. So not let, I should say here, rather put t equal to 0. Just a minute, yeah. So when you put t equal 0, LHS is independent of t, so it always remain 1. So this is a, this is gone, you got a. Then as I said, the second linear factor, which is 1 plus t, of course whole square, but the factor, one of the factors is 1 plus t also, so replace it with 0, and then what we get t as? T is minus 1. So again this is 1, this is 0. When you put t is equal to minus 1, that term gets 0. So this is minus b. So b is minus 1. So you got two values. Now for third value, I will just say put any simplest possible value. So of course the value for me left is t is equal to 1, which is unused. So again we get 1. Now a we already have. Okay. So a 1 plus 1 is 2. So this is 4. Okay. Minus 2 because t is 1. Okay, and b is minus 1. I'm sorry, so it's not 2, it's minus 1 here. Yeah, minus 1, and then it's c, so this is plus 2c. Okay, so this is 3 here, so 2c is equal to minus 2 and c is again minus 1. So what does that mean? That means, so I can write this as dt 1 upon t into 1 plus t whole square. So we can write it as, so what is a? A is 1 upon t, and both are minus 1. So 1 upon t minus 1 upon 1 plus t minus 1 upon 1 plus t whole square. So therefore the integral is, so I is nothing but integral of 1 upon t into 1 plus t whole square with respect to t, and we know that integral gets distributed over addition or subtraction. So just distribute it, so you will get integral of 1 over t with respect to t minus integral of 1 over 1 plus t again with all respect to t minus integral of 1 upon 1 plus t whole square with respect to t. We all know the integral, so ln of mod t minus ln of mod of 1 plus t, and then plus 1 upon 1 plus t plus c, and at last we all know we will be replacing t by x into e raised power x. So if I use the log property, ln a minus ln b is nothing upon ln a x into e raised power x upon 1 plus x times e raised power x within mod. Okay, and then plus 1 upon 1 plus x e raised power x plus c. So that's the answer from my side for this integral, bachcho, the first question here. Okay, so that's the solution from my side, where we use method of substitution and the partial fraction. Okay, so we will be solving the next question in our next video, bachcho.